Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome again, dear students. This is Teacher Pasco, your teacher of chemistry. Today, I will be with Senior 1 students. In the previous lessons, you have discussed the different types of mixtures and different types of substances. You remember that we have pure substances and mixtures. Do you remember some of the examples you gave for the pure substances? Do you remember some of the mixtures you gave as examples? I'm very sure you do. But have you ever think of what may happen if you take a substance and divide it again? If you ever thought about that, then you were on the right path, as any scientist would be. Because you are not the only one to think about what will happen if you take matter and divide it into many pieces, smaller and smaller and smaller pieces. Somehow, it is the same as how you can separate the components of a given mixture. We consider a mixture to be something very big, but when you separate the components of those mixtures, you get components which may be considered to be smaller. So what happens when we take matter and divide it into smaller parts and smaller again? Think about it. What do you think will happen? Are we going to undergo division or to continue dividing matter endlessly? Or you think that at a given time we will reach to a particle which cannot undergo further divisions? If you think that at a given point we will reach the smallest particle which cannot undergo further divisions, you are right. If you take a piece of chalk like this one, for example, and divide it into two parts, you get two parts which are smaller than the original piece. So they are smaller than the original piece. If you take one of the two pieces and divide it again, you get even smaller particles or even smaller parts which are smaller than the original piece and smaller than the first piece. And if you go on dividing, what happens? You get even smaller pieces. And if you go on dividing and dividing, at a given point, you will reach the smallest particle. And that smallest particle is the one scientists, alchemists, have called atom. An atom. As I said, if you take a large piece, divide it into smaller pieces, you go on dividing it into smaller pieces, and you go on dividing into smaller pieces, you will end up by finding a very, very small piece, which cannot undergo further divisions. And we call that particle an atom to mean what? To mean indivisible. Atom comes from the Greek word atomos. Atomos, which means indivisible. And by definition, an atom is the smallest particle of matter. An atom is the smallest particle of matter that can exist free in nature. It's the smallest particle of matter that can exist free in nature. So what do we mean here? We mean that all materials we know, every type of matter we know, it is composed by atoms. So when you join so many atoms, you will end up forming matter, what we know, what can be seen. Some of the characteristics of an atom one of them is that an atom cannot be seen with a naked eye. You cannot use your eye to see the atom. It's not possible. Why? Because it is very small. Very, very small. So, atoms, they are the building blocks or building units of matter. As we said, every kind of matter is composed by atoms. That is the definition of an atom. Now, what is an element? Our lesson today it is elements, atoms, and molecules. What is an element? What do you think an element is? An element is composed by atoms of the same type, of the same kind. So, if we take our very small particle, this has a very big size compared to the atom. So if you take atoms of the same kind and combine them, what you get is an element. So an element it is a combination of atoms of the same kind. When you are studying pure substances and mixtures, you give the example of metals as being pure substances. Some metals are pure substances. Let us take the example of iron. We all know iron. It's a metal we use in buildings, for example. It is a metal we use to make knives for cutting things. So it is a metal we use to make car bodies. So that iron, it is a pure substance. And the iron we are talking about, it is composed in its pure form, it is composed by the same kind of atoms. The building blocks forming that pure metal, they are all of the same kind. They are identical. So because of that, we call that iron an element. And one of the characteristics of elements is that you can produce elements if you take matter and divide it. An element is the smallest particle or the simplest substance you can get if you divide matter. So an element is also the simplest substance that can, say, the simplest substance or component of matter that can be produced by chemical reactions, by a chemical reaction. So if you take your piece of chalk, for example, the piece of chalk we are using, of course, this one is a compound. So it is matter, but which is composed by different atoms. And if it is composed by different atoms, remember we said that many atoms of the same kind, they form an element, then our piece of chalk is composed by different elements. So if you take this piece of chalk and divide it up to the point that when you are saying divide, this is physical. Why is it physical? Because the piece we have here and the piece we have here, as well as the large piece, they all have the same properties. So we don't have a new substance formed. So the change we are bringing about is a physical change. It's not a chemical change. A chemical change brings out a new substance, but a physical change will give you something which is exactly similar to what you started with. So if you divide the chalk into different pieces, but you use chemical means, if you use chemical means, you will produce elements. And that is the reason why we are saying an element can also be divided as the simplest substance of matter that can be produced by chemical reactions. So, as a summary, we start from the atom, which is the smallest, and many atoms, when joined together, they give what? They give an element. Many atoms of the same kind. Remember, it's many atoms of the same kind. When they are joined together by chemical means, they give us an element. Now, we understand the meaning of an atom and an element, but what is a molecule? Before we go to the molecule, let me give you an example. Let us consider the house. A house is a very big structure which is composed by small components, small parts. And if we consider the bricks, those bricks can be considered as being atoms. They are the building blocks of the house. So, if you take a house and consider it to be an element, then it will be composed by the smallest parts, which are those particles compared to the atoms of the same nature. So if you take a house and divide it into different parts, you can start with walls. Those will be bigger than the bricks. But if you continue dividing the walls, you will end up by reaching a brick, which is smallest. And in that case, we can compare it to an atom. Divide matter at a given point, you will produce the smallest particle, which is called an atom, from the Greek word which means indivisible. So the atom cannot undergo further divisions. And when we combine atoms of the same nature, of the same kind, we make what we call an element. Now, what is a molecule? A molecule is a combination of atoms of different types or of the same types by chemical means. When atoms are combined by chemical means. A molecule is formed. Here the atoms can be different. Atoms may be different or similar. If the atoms are different, we get a new compound or a molecule. But if the atoms are similar, we get an element. So a molecule can be composed by different atoms or composed by same atoms. And if it is composed by same atoms, then we call that an element. Okay? For example, we can consider water. Water is a substance composed by hydrogen, an element we call hydrogen, and another element we call oxygen. So we have the elements, and now let us have a look at how we name the elements. We know different names of elements, and today we know more than 100 elements. And those elements have different names. Naming elements. The lightest element, the smallest element, is called hydrogen. The other element which composes water is oxygen. We have so many elements. You know the metal, the precious metal we call gold. You know another metal we call iron. We have so many elements. And how do we name those elements? Sometimes it is necessary to use symbols to represent things. You know that. You can use an image to represent a phone. You can use an image to represent a television, a screen. So we can also use symbols to represent elements. Some elements are represented by using a single letter, while other elements are represented by using 2 letters, and some may even be represented by 3 letters. Every time if it is a single element, like for hydrogen, we use the first letter, and it is always capital. Oxygen, it is O. For nitrogen, it is N. But if we have an element like magnesium, we use 2 letters. The first letter is capital and the second is small. You can see that if you use your periodic table. And some elements have names which are very different from, whose symbols are different from the names we know, the common names we know. And here we have the examples. We have the examples here. We have potassium, the element potassium. Its symbol is K, and it is from kalium. So these names are non-English names, which can be Latin names, Greek names, German names. It depends. So here we have tungsten, for example. And the name from Germany is Wolfram, and then the symbol is W. Silver, which is also called argentum, it is represented by Ag. So some elements are represented by symbols which comes from names derived from other languages. Now, what are the components of an atom? We said that the atom is the smallest particle of an element. But actually, it is also composed by other particles. And the subatoms atomic particles which are known, we have a proton, we have a neutron, and an electron. If we consider an atom to be having a structure like this one, then here we have the nucleus, which has some particles. The particles are different. And in the nucleus, we have two types of particles. We have a proton, it is in the nucleus, and we have a neutron, which is also in the nucleus. But around the nucleus, we have other particles, which are the electrons. Here it should be noted that the proton has a mass, and the neutron has a mass, and the electron is almost massless. So the properties we have here, for the proton, mass is the relative mass. We consider it to be 1, while the charge of this proton is positive 1. For the neutron, the mass is 1, but a neutron is neutral. Neutron, you can see there is neutral. And for the electron, the mass is almost 0, or 1 over 1,840, and the charge is negative 1. So these are the different subatomic particles, the parts which compose the atom. Okay? Now, from this, we can see that atoms are the smallest particles of matter, but which are also composed by even smaller particles. We said that atoms of a given element are similar, but some of them may be different, and they may be different simply because they have different what? They have different neutrons. If they have different neutrons, then they will be different. And the different parts, the different types of atoms, we call them isotopes. We will define what an isotope is, or what isotopes are, but before we define the isotopes, let me tell you what we mean by atomic number and mass number. The atomic number, this is the number of protons. The number of protons, which is very important because it represents a given element or atom. And the mass number, this is the number of protons plus the number of neutrons. And the atomic number is symbolized by Z and the mass number by A. So if you have an element like iron, for example, and you want to represent it, you represent it like this. Iron, that is the chemical symbol, and up here you put the value of A here, and Z here. This is the chemical representation of our iron. And the atomic number of iron is 26, while its mass is 56. You can read this from the periodic table. So this is how we represent an element. Generally, it is X standing for a given element, and here we have A and Z. So here it is 56 and 26, conventionally. Now, let us go back to the isotopes. What are isotopes? We said that isotopes belong to the same element. So they have same identity, same atomic number, but they have different masses. So isotopes are atoms of the same element which have different neutron numbers. Different neutron numbers. We can take the example of chlorine, which has 17 as the atomic number, and the mass, which is 35, but for the other isotope, it is 37. You can see that here we have 20 for the number of neutrons, and here we have 18 for the number of neutrons. It is very important to always remember that in a neutral atom, in a given atom, the number of protons is equal to the number of electrons. Being positively charged, the protons, and negatively charged, the neutrons, and present in equal numbers, then the atom will be neutral. So you can represent all elements, and you will try that. AXZX stands for the symbol of a given element. Now, before we close today's session, let's have a look at the homework you will try. Question number 1. What is an atom? We have explained and defined the atom. State the subatomic particles and their respective properties. The respective properties I'm talking about, it's the mass, the charge, and you will also identify the location of those particles. Are they located in the nucleus or around the nucleus? And question number 2, an atom of iron has 26 protons and 30 neutrons. What is the mass number of iron atom? Mass number, which is A, it is given by formula by Z plus N. N is the number of neutrons. So from here you can calculate the value of Z, the value of N, or the value of A if any two of the three values are known. So you will determine the mass number, and after that you write the symbol of iron showing its atomic number and the mass number, AXZ. And you can also write the symbol of the element sodium. And number 3, you will define the following terms. Atomic number. What do you understand by atomic number? By mass number. And what do you understand by the term isotopes? I think now we are almost at the end of our lesson. And before I say bye, let me thank you for your attention, for your participation, for always watching and following the lessons on TV. I hope to see you next time. Thank you.